going to look into our first organic question, and this is on question 9. So there's a total of 13 marks here, which is really decent for organic questions. So let's move into it. For the first part of the question, they're telling you products are from this question is on product from crude oil. They say most of the compound of crude oil belongs from the same homologous series. So if this is the first time you see this word, okay, you can simplify it by thinking of this word as family. In organic, in iGCSE organic, we have 4 families. The first family here is our alkane. Okay, so the first one that we're looking into, how do we know that it is alkane and not the other 3 families? The other 3 are this alkene 1, 2, and then 3 is alcohol, followed by 4th one is carboxylic acid. Okay, so how do we know? The clue here is the product of crude oil will all be from alkane. However, there are some students who would write the incorrect word, and that's alkene. When would alkene come into play here? It's when the crude oil, the fractions. So we have crude oil, and then after it goes through fractional distillation, we get the different fractions such as petrol, diesel, fuel oil, etc. Right? So all of this, especially those at the bottom like fuel oil and bitumen, they can undergo cracking. So it's after cracking, then you will get some alkenes. Okay, so this is when students get confusion, so take note of this. Okay, so the answer to the first part of the question is alkane. Now we're going to move on to B. So we're talking about fuels are obtained from fractional distillation of crude oil. Explain how the combustion of common impurities. So this is when the first keyword comes in. You need to identify the impurity, and this impurity can cause acid rain. So you need to know that when it comes to combustion, we look into the most common fuel that is in the highest demand is petrol. So what is in petrol as an impurity is actually our sulfur. Okay, so to identify the common impurity here is sulfur will get you the first mark. Take note, this is a 3-mark question. Then followed by the word explain. So you need to emphasize on the why. Okay, what's wrong with having sulfur in the fuel? In this case, in petrol. Okay, so when we burn petrol, we are also indirectly burning the sulfur in the petrol as well, because we are burning this impurity. So what forms is sulfur dioxide? So for those of you who needs a very visual representation, the chemical equation is here. So you've got sulfur plus oxygen gas. Take note, oxygen gas is diatomic molecule, so it must be O2. You get sulfur dioxide. Now when sulfur dioxide dissolves in rainwater, that's when we get the acid rain. Okay, so again, what are some of the misconceptions that students are writing? It's they identify that, they think of acid rain and they think of like, nitrogen oxide is one of the contributor for acid rain. So they think about they think in the line that impurity here is nitrogen, but it's actually not. Okay, so if you mention anything about nitrogen or nitrogen oxide or oxides of nitrogen, you will not score full marks for this question. Again, for those of you who wants a visual representation of what happens when sulfur dioxide dissolves in rainwater, you actually form a strong acid. Okay, so that's how we get our acid rain. Okay, moving on to part C. This is a very common question. They talk about cracking here. Okay, so we start off with a really long alkane molecule, and what happens here is we break down the long molecule into something shorter and more useful. So they like to ask the condition for catalytic cracking. As name suggests, there's catalysts involved. There are 2 possible catalysts. One is alumina and one is silica. In case you want the formula, it's essentially this 2. Okay, so I'm going to match silica to this, and then alumina is essentially aluminium oxide. Okay. The temperature here would be the range of 600 to 700 degrees Celsius. Don't put things like above 600 because that's really vague, right? What's above 600? Is it 600 to 6,000 kind of thing? So provide this range, it'll be safer for you to get your full 2 marks here. Finally, we're looking at part 2 of this extension. Explain why cracking is useful. Again, this is a really popular question. 3 marks here, easy to score. So you need to understand that cracking gives us 2 products. One is alkane and one is alkene. right? So this alkane, the first product here, this alkane here, is actually shorter than the original. Okay, why is shorter alkane better? Okay, so let's look into our answers. So cracking produces short chain alkane and they are more useful. Instead of using more useful, you can also use that they are in higher demand and because they can be used as petrol. The reason why they are more useful or they are in higher demand is because this shorter chain alkanes here, what happened to my pen, okay, they are more flammable. Okay, so it's easier to combust, so they are actually better as fuel. Next, what is the other side product? The other side product here we have is our alkene, the CC double bond family. Okay, so why are alkene useful? I'm going to use yellow. It's because they are starting material to make polymer, which essentially is the plastics as well as alcohol. So that's how you actually get your marks here. Again, how do you get your marks? You identify what is the product, and so here, alkane, identifying a short chain alkane is formed is 1 mark. Uses of it, 1 mark. Identify alkenes are formed. I would think like in this, because it's a 3-mark question, this would be considered first mark because by identifying alkene and alkenes are formed because the equation is already provided, right? So you won't get double marks for that. And then the uses of alkene, CC double bond here, will get you your 3rd mark. Okay, so that's essentially how the marks can be awarded. All right, part D. Again, we are looking at a very popular question on identifying or defining what isomers are. Isomers are basically substances or molecules with same molecular formula. And what do we mean by that? For example, if we use the bottom one as an example, molecular formula can be things like C5H12 or like C2H. Usually we go with something longer, like C4H10 example. Okay, so the molecular formulas are the same, but what do they differ? They differ by the structural formula, basically how it looks. I prefer the word display formula though, because you'll see why. Okay, display formula basically is what we are looking at this portion. This is basically when all of the bonds, okay, all the lines are being shown. That's what we call our display formula. But when it comes to definition, they accept both structural and display formula for differences. Okay, so identifying the similarity and the differences, one similarity and one differences will get you your 2 marks here for this definition question. Another way to word out molecular formula, just in case you cannot remember, is they also accept if you say these isomers have the same number of carbon and hydrogen. Let's use the drawing at the bottom to prove this point on the top. Okay, so here we have a molecule. This molecule is made up of 5 C's as well as 12 H's. Okay, so the basic structure here will always be a straight chain molecule. Straight chain basically means the C is in a row, in a straight line. Okay, so this is the most basic way of drawing a molecule. Then they want you to draw 2 other isomers. So when you are drawing, you always need to make sure that at the end of the day, you have got 5 carbon and 12 hydrogen. And because the original molecule, they're all single bonds between the C's and the H's, you need to make sure that is your 3rd criteria as well. Okay, so the 3rd criteria here is single bond. Alright, okay, so these are the potential answers. So you can draw one like that. The one on the left hand side is like a cross. Okay, the C's are in a cross, and then for the one on the right hand side, the isomer here, we've got 4 in a row. Okay, 4 in a straight line, and then you've got 1 extended C at the bottom. And if you fill in the top, okay, the extension out, you will have 12 hydrogen. Now, when it comes to drawing, things to take note, okay, things to take note is each carbon should only have 4 bonds. The reason because for this is carbon belongs to group 4, so it can only hold on to 4 other atoms in that case, okay, or bond with 4 other atoms, okay. So similarly, if you were to draw out all the H's for the first the isomer on the left hand side, you will also end up with only 12 hydrogen. So this is to make sure that you are on the right track So again, when it comes to checking your answers, you need to always make sure the C and the H's are the same as the original. And because this is an alkane, which is CC single bond, then all of your isomers should only have single bond. Okay. Now, what is considered a wrong example? I'm just going to show you. Now, for this, say for example, you have drawn this, and your next example, you drew things like, I'm just going to use black. Okay. Sorry, still saving. This must be a large file. Okay. So if you draw things like this, okay, 4 in a line, and then you extend the other C over here. Okay, why is this not an isomer? Or okay, it's because if I were to label my C's, okay, this would be C number 1, 2, 3, 4, and at the second C, okay, there's an extension out. Okay, now these two are essentially just mirror image of each other. Okay, so what this means is if I were to put a mirror over here, I will actually have the exact same molecule that I see here. So C number 1 and C number 2, and at C number 2, you get this extension outwards. Okay, so if you have drawn this as an isomer, please take note, do not draw the one at the bottom because they are essentially the same molecule. Alright, so with that, we've got 30 marks over here for our first organic question. Do you have any other question on this, or if you want me to do a little bit of extension for any part, just drop me a DM. If not, I hope you will like, subscribe and share with a friend that you find this useful. See you on the next one.